looks like a horseshoe. So here it is. You would expect information to be traveling rapidly from one hemisphere to the next. And that's the best one we have here. In some of the models you can actually take it out. This is actually what they used to sever and still do sometimes for epileptics to prevent grand mal seizures. They're going to sever the two halves of the cerebrum so that the information cannot travel electrically from one side to the other. So maybe that'll help. Septum pellucidum is that, again, that flap of tissue that we have to cut through in order to get to the ventricles. The fornix they've gone ahead and put on in this pink color, so it's always really clear, and they always show it in pink. So even if we look at this other model, it's still in pink there. I don't know why they do that, but they do. There you go. The cortex is obviously all of that. I don't know why that's separate. Olfactory bulbs. So now we're going to get into cranial nerve land. So I'm going to put the brain back together since we're looking underneath it. The olfactory bulbs are the very end. Okay, so this is what's going to sit in that ethmoid bone, and then the tract, the olfactory tract, is actually what takes the information back. So notice that really and truly, the way that it's named, the olfactory nerve is not truly a cranial nerve. It's actually a projection of the brain itself. The optic nerves extend out from here, and we just see little stumps of them that they've cut off. The optic chiasm is this area right behind the pituitary. It's a little bit hard to see with my big old fingers in the way, but here it is. This is where it's the X portion. This is where the two halves of the visual world go ahead and get together, and the left goes to the right half of the brain and the right goes to the left. So it's where that nasal half of the world switches sides. The optic tract is in the area where it finally takes back to the brain all that information. So we have nerve, then chiasm, then tract back. Now what's cool is that each of the brains, if you look really closely as you study, is labeled 3, then it shows you 4, 5, 6. It goes through all the nerves with you. So what I recommend you do is start on the side where it's labeled and learn to count them. And count them in order so that you're going 3, 4, 5, 6, so forth and so on. If you count them in order every time, then you'll be able to count them. You'll come up with a muscle memory to count them in order as you move. And it can also help you if you look at that for a few minutes today and get the counting down. And again, they're labeled. So start on this side, going 9, 10, 11, and then back up to 12. And then see if you can apply it to this side. And once you can, you know where they originate from and all that good stuff. And then we did all the rest of it. So we could go into the diencephalon if you want. Do you want to keep going? Okay, so we have the pituitary gland, which is this bad boy that hangs down. They want you to know the infundibulum, which is the white stalk, if you can see it inside there, that connects the pituitary up. They also want you to be able to identify the mammillary bodies. Here they are, deep inside. Let me show you this from the side, too. When you look at it from the side, here's the optic nerve. Here's where the actual information of the optic chiasm crosses. This one in the back is the mammillary body. So you make sure that you can do it both ways, because I find that sometimes students they can only see it sideways, or they can only see it like this, and then they can't identify it on the practical. So make sure you look at it from the side. The thalamus we've already looked at. Here's the place where it joins. The massa intermedia is in brown here. The hypothalamus is this lower portion. It looks like it's got a little mouth to it down there. The pineal body is all the way at the other end. Here's our pineal body over here. Okay, that's the bulk of the epithalamus. The interventricular foramen you can ignore. It's not on here. Some people will tell you it's through that space, but it's such a crappy thing. And then that's it for the diencephalon. Then we go down to the cerebellum. The cerebellum, you need to be able to recognize right and left hemispheres. But don't worry, I'm not just going to put a little portion out and go, which is that, okay? That's not going to happen. It's going to be attached to the brain, so as long as you know which half of the brain you're at, you're good. The vermis is actually the sort of, it's horrible on these models, and I don't know if it's better on this. Yes, it is a little better. You can see these little wormy-like attachments that go across. These are the vermis, okay? And in real life, they actually do look like they almost come together at the back of the brain. The cortex is everything else. It's this outermost layer. And then the arbor vitae is the white tree-like structure inside. Tree of life. Then we get down to the brainstem, where we had the thing that I couldn't remember, the cerebral aqueduct here. But then we also have the fourth ventricle. Now we get to the part where we get midbrain. Okay, so I need to get out my actual little brainstem model for this to see it real clearly. So to orient ourselves again, this is thalamus, this is the pituitary, that's the optic, we can see the mammillary bodies. This area in here is midbrain. This is what it would look like from the pituitary side. If we flip it over, this is also midbrain. Okay, so again, be able to recognize it from both sides. This is the corpora quadrigemina. Okay, it's composed of 4 bumps. That's how it gets its name, 4 bodies. And they look like twins, so that's how it gets its name. Each of them, the 2 upper ones are called the superior colliculi and the inferior colliculi. These are auditory and visual reflexes. You'll see that they're huge in sheep, which is why sheep have that really weird reflex where you can startle them with a noise and they actually will play dead. They'll actually fall over, play dead. Okay, there's that. Now if we turn this around, we said that this was also part of the midbrain. These little pedestals that look like they're kind of holding up the thalamus, those are the cerebral peduncles. So this is one cerebral peduncle and the other cerebral peduncle, where we see information really traveling up to the thalamus. Then we have the pons. The pons is really this projection here, these like pods on the front. If we open this up, you can see that it really does look like its own thing here. Okay, this own little pod of information. That's the pons. So do we have middle cerebellar peduncles on here? I didn't even think to look. They want you to know the pyramids, which are these guys, and the medulla oblongata, which is what it's part of. Then I'll need to look real quick and see if we have the middle cerebellar peduncles on the model. Let me look. Oh, there we don't. No. I know there's the one we have it on. It doesn't even look like we really... Maybe what they're trying to show here, I think this is what they're trying to show as the middle cerebellar peduncles. It takes information from the brainstem over to the cerebellum and back again. We have in superior and inferior, but I think they've cut to only show you the middle cerebellar peduncles. I bet you that's what they're trying to show you there. And that's it. Now when you look down at your sheet in the meninges section, you want to understand that we don't really have any of that. We don't have a single brain model that actually has all the meninges on them. So the place that the meninges is going to be found is back in that model over there. Okay? Now, what that means is that because the dura mater only fuses to bone in the skull, right? There is no periosteal layer that we have. So we can get rid of all of that. Now, the only thing that I want you to keep is the tentorium cerebelli and the falx cerebri, because I could put those in as, the last two, the tentorium cerebelli and the falx cerebri, we'll actually keep those in. And what those are these big flaps of the dura mater that come into first the longitudinal section, and then they come back in here to divide off the cerebellum. And there's really cool pictures of those online, and I'll show you guys next week what it would look like. You can actually like pull it off and it looks like the brain has an inside mohawk. It's cool. So we'll look at that together. But other than that, that's your noggin.